Welcome to this introduction section on Terraform. In this section, we'll be understanding what is Terraform, why do you need Terraform, and what are the use cases for Terraform. When should you use Terraform and when should you not use Terraform? After that, we'll look at the other tools in the infrastructure as code space. We will look at how Terraform compares with other tools that are present in infrastructure as code. We will look at one of the prominent tools in the infrastructure as code space, which is Ansible, and we'll compare it with Terraform. Ansible does something called configuration management, and Terraform does something called infrastructure provisioning. That's the main difference between these two tools. We will dig deeper into that in this specific step. After that, we will go into how you can use Terraform to create resources. What are the steps involved? And we'll talk about why Terraform is called a declarative tool. After that, we'll get started with a few important commands related to Terraform. At the end of this specific section, we will talk about Terraform plugin architecture. How can you extend Terraform architecture by adding in plugins? We will talk about something called providers, which are plugins which can be added to the Terraform ecosystem. And we'll also talk about how you can use Terraform providers to authenticate to different cloud platforms. Are you ready to dig deeper into Terraform? I will see you in the next step. Let's get started with talking about what is Terraform. Let's first talk about the need for infrastructure automation. Manually creating servers, networks, databases, and permissions for every environment, dev, QA, stage, production, is slow and error prone. You might have multiple environments like dev, QA, stage, and production, and you will have multiple instances in each of the environments. You want to create a virtual server. You might want to create a virtual network. You might want to create a database. And in each of the environment, you would want to repeat all these steps. If you do this manually, it's very error prone and it would take a lot of time. And that's what you would want to avoid. That's when you would go for an infrastructure as a code tool like Terraform. Terraform is an open source tool that lets you define and provision cloud infrastructure using simple declarative configuration files. It solves for repeatability and consistency. Your entire infrastructure is defined as code. You can version control it. You can review it and reuse it across teams and environments. So if I would want to use a simple piece of code to provision a dev environment, once the dev environment is ready, I can use the same code to provision QA environment. I can use the same code to provision stage environment and the production environment as well. So that's what Terraform enables you to do. It ensures repeatability and consistency. I can also be sure that the same kind of environment is created in dev, QA, stage, and prod because we are automating everything. The QA environment is not created manually. It is being automated, and therefore we are very confident that the same kind of environment exists in dev, QA, stage, and production. You also have consistency. It eliminates manual infrastructure setup. Terraform automates the provisioning of servers, databases, and networks, and therefore you will not have any manual errors or manual delays. One of the biggest advantages of Terraform is that it can work across cloud providers and services. It works with AWS, Azure, Google Cloud. You can use Terraform to provision Kubernetes clusters and manage things on Kubernetes. You can use Terraform to provision GitHub repos and play with them. You can use Terraform to play with Docker. So Terraform works across cloud providers and works with a lot of other services as well. So you can work with AWS, Azure, Google Cloud, Kubernetes, GitHub, Docker, and a lot of others using the same tool and very, very similar syntax. Now that you have everything in code, we are making use of code to provision our infrastructure. So you have a piece of code which can be used to create your environment. Therefore, you can also start using version control. You can put your infrastructure code in version control and you get all the benefits you would get with version control. You can monitor changes over a period of time. So you can track changes over a period of time. And you can involve your team in reviewing your infrastructure code and giving you feedback. So your infrastructure code changes can be reviewed, tested, and approved just like application code. So by using Terraform, you can bring the same processes around your infrastructure that are possible around your code. You can bring in a version control process. You can bring in a review and test processes as well. In addition, similar to code, you can also integrate your provisioning of infrastructure into your CI/CD pipeline. So this can enable automatic infrastructure updates as part of your DevOps workflows. As soon as you commit your infrastructure code to the Git repo, you can enable automatic provisioning, automatic execution of these scripts and provision infrastructure in cloud, update infrastructure in cloud. The last benefit we'll be talking about is reducing cloud costs through automation. Once you have made use of all the resources, let's say I would want to terminate the environment. If you're doing manually, there is a chance that you might miss resources. However, if you're using infrastructure as a code tool like Terraform, you know that it will automatically tear down everything that is in the environment. So you can easily tear down all the unused infrastructure without missing any resource. So you can reduce your cloud costs through automation. In this specific step, we started with talking about Terraform. We talked about the fact that Terraform is an infrastructure as a code tool. It's an open source tool that helps you define and provision cloud infrastructure through simple declarative files. For me, the most important thing about Terraform is that it allows for repeatability and consistency. You can define your infrastructure as code and you can use the same code to provision multiple different environments. So it ensures repeatability and you are also sure that these environments are the same. They are consistent. Let's dig deeper into Terraform, starting the next step. Are you excited to learn more about Terraform? I will see you in the next step. In this step, let's talk about when should you use Terraform and when should you not use Terraform. So when should you not use Terraform? That's what we'll be getting started with. When you need fine-grained configuration management. What is configuration management? I have a server and on the server, I would want to install an operating system. I would want to configure a few files. I would want to install a few processes. And I would want to manage the operating system which is running on a specific server. I want to make a change to the operating system configuration. That's what is configuration management. Managing OS configurations, package installations, and runtime processes on the server. So this is inside a specific virtual server. That is what is called configuration management. Tools like Ansible, Chef, and Puppet are great at that. They are great at configuration management. So if your task is focused on fine-grained configuration management, maybe Terraform is not the right tool. Next is when your infrastructure is small and rarely changes. So your infrastructure is very, very small, maybe a couple of servers, and you don't have a lot of environments. In that kind of scenario, Terraform might be a overkill. It might add unnecessary complexity. If you have very, very less infrastructure to manage, then probably you might not want to use Terraform. At a later stage, when you see that the infrastructure is starting to grow, that's when you might think about Terraform. Next, when your team prefers GUI-based provisioning. If your team is non-technical or prefers clicking through the cloud consoles, Terraform's code-first approach might not be ideal. When you're using Terraform, you need to use Terraform's language called HashiCorp Control Language or HCL. You use HCL scripts to provision your infrastructure. Your team needs to be a little technical to be able to manage HCL scripts. If your team is non-technical and they prefer clicking through AWS, Azure, Google Cloud consoles, then probably Terraform's code-first approach may not be ideal. When you want quick one-time changes, If you're making temporary changes, quick changes, then probably using the cloud provider console or CLI may be faster than writing and managing Terraform code. The next scenario is when your team lacks Git practices. When you use Terraform, you are using infrastructure as code. You are writing your infrastructure as code and you are using it to provision your infrastructure. And therefore, you need to have proper version control in place around the script you are writing, around the code you are writing to provision infrastructure. If your team does not want to use version control or Git practices, in that kind of a scenario, it might not be the best tool. Terraform works best when used with version control workflows. Without it, it might not work well. So these are some of the situations where you should not use Terraform. Now, what are the situations in which you should use Terraform? When Terraform is recommended approach, when you'd want to automate complex cloud infrastructure, if you want to provision VMs, databases, networks, security groups automatically in the cloud, then Terraform is the right tool. You can automate provisioning everything without doing anything manually. When you need repeatable environments, if you want to create identical dev, QA, and stage and production environments, so you want to reduce environment-specific problems. You want to ensure that these environments are consistent. That's when you can go with Terraform. When you're managing multi-cloud or hybrid cloud, the great thing is Terraform works across AWS, Azure, Google Cloud, and on-premises. So it's great for teams using more than one platform. When your team wants to use infrastructure as code, if you want to implement infrastructure as code, I think the number one tool out there is Terraform. This allows you to store infrastructure definitions in Git for better collaboration, review, and rollback. When you'd want to integrate infrastructure into your CI/CD pipelines, when you'd want to provision infrastructure directly based on a CI/CD pipeline, Terraform is a great fit in that specific scenario. When you want to adapt immutable infrastructure practices. What is immutable infrastructure? Let's say you created a server. What would we do if we need a small change on the server? Typically, we would go and directly make the change on the server manually. That's not a good practice, because if over a period of time you keep making a lot of changes to the server, after some time, if you want to recreate the server, you don't know what are the steps involved. That's where immutable infrastructure comes into picture. Let's say I have a server. If I need to make a change, the best practice recommended by immutable infrastructure is to provision a new server with the new configuration. So use code to provision the new server with the new configuration. So whenever there is a server created, I know that the latest code is in version control and I can reproduce this at any point in time. We will discuss immutable infrastructure a little later in this specific section as well. However, important thing to remember is that if you want to adapt immutable infrastructure practices, then Terraform is a recommended option. In this specific step, we talked about when should you not use Terraform and when should you use Terraform. If you need fine-grained configuration management, if you have very small infrastructure needs, if your team prefers GUI-based provisioning, if you want to do a quick one-time change, and if your team lacks Git practices, if your team lacks version control practices, in those kind of situations, Terraform is not the recommended tool. However, if you want to automate complex cloud infrastructure and get repeatable environments, and you want to do this across multiple clouds, and you want to use great practices like infrastructure as code, CI/CD pipelines, and immutable infrastructure practices, then Terraform is definitely one of the most important options for you to consider. I'm sure having a great time, and I'll see you in the next step. In this step, let's talk about how Terraform compares with other tools that can help with infrastructure as code. Let's start with cloud-specific tools. So the three tools which we'll be talking about in here: AWS CloudFormation, Azure Resource Templates or Bicep, and Google Cloud Deployment Manager. These are all cloud-specific tools. You can use them only on the specific cloud. So AWS CloudFormation, for example, is native to AWS. It allows defining infrastructure using JSON or YAML. You can define your AWS resources in JSON templates or YAML templates, and you can use it to provision AWS infrastructure. It's great for deep AWS integrations, but lack multi-cloud flexibility. Next, ARM templates. ARM templates is native IAC tool for Azure. ARM uses verbose JSON templates. If you want to write code and provision Azure resources, you can make use of Bicep. However, the important thing is ARM and Bicep. Both of them are things which are specific to Azure. So these are best only for Azure specific projects. Next, Google Cloud Deployment Manager. It's a Google Cloud native tool using YAML and Jinja 2 templates. It's suitable only for Google Cloud only setups. It's limited outside Google Cloud. So these are all cloud specific tools. You would see that most cloud platforms offer a YAML based tool, and also they'll have a code based tool as well. For example, in AWS, you have something called AWS CDK, which also allows you to use code to provision your infrastructure. So each of the cloud platforms typically allow a YAML based and a code based provisioning of infrastructure. However, the key thing is that would be restricted only to the specific cloud platform. And that's why typically you would want to go with a cloud neutral tool. Once you have your team equipped with the skill of using the cloud neutral tools, they can work with any cloud platforms, AWS, Azure, or Google Cloud, or these cloud neutral tools typically work with on-premises resources as well. So you can use them to provision resources on-premises as well. So what are the other alternatives to Terraform which are not cloud specific? The first option you need to consider, and this is something I would consider as a direct competitor to Terraform, is Pulumi. Pulumi is also infrastructure as code. Pulumi does almost the same things as Terraform. However, in Pulumi, you would be making use of code. So you'll be using languages like Python, JavaScript, TypeScript, Go. You will use these languages to write your infrastructure. So instead of using HCL or HashiCorp language, you'd be using a language which you are already familiar with. If let's say a programmer is already familiar with Python, probably they would be preferring to write Python to provision infrastructure as well. This would avoid the need for learning something like HCL. So there are a few advantages for Pulumi. Pulumi does the same thing as Terraform, but in Pulumi, you'd be making use of a familiar programming language like Python, JavaScript, TypeScript, or Go to provision your infrastructure. So this is best for developers who want to automate infrastructure as code using familiar programming language. One challenge with using code is that a lot of operation folks might not be familiar with writing well-structured code. They might be able to write a quick code snippet or something to get something working, but they might not be familiar with writing organized code. So that's a challenge I typically see when you're using Pulumi to provision infrastructure. Next are configuration management tools. So configuration management is configuring and managing applications, processes, and files on existing servers. Infrastructure as code typically focuses on provisioning the servers. There will be a little bit of configuration management as well. However, the major part is provisioning servers. Similarly, for configuration management, the focus is on configuring something on an already provisioned server. There might be a little bit of provisioning involved. However, the major work the configuration management tools focus on is configuring an existing server, configuring and managing applications, processes, files on existing servers. The three major configuration management tools are Ansible, Chef, and Puppet. All these three tools are great at configuration management. You can configure and manage applications, processes, and files on existing servers. However, they are not so great at creating infrastructure, at provisioning infrastructure. So if your work is majorly focused on configuration management, then I would recommend you to think about Ansible, Chef, and Puppet. Terraform might not be the right tool. However, if your work is majorly focused on infrastructure provisioning, in that kind of a scenario, I would recommend you to use Terraform as your first choice. In this specific step, we talked about how Terraform compares to other tools with respect to infrastructure as code. I will see you in the next step. In this specific step, let's compare Terraform and Ansible. I just wanted to give you a key difference, which is between infrastructure provisioning and configuration management. And let's compare two tools which are good at that, Terraform and Ansible. Terraform is focused on infrastructure provisioning. A similar tool might be Pulumi. And Ansible is great at configuration management. Similar tools are Chef and Puppet. So this comparison mostly applies for any tool which is doing infrastructure provisioning versus any tool which is doing configuration management. We will be using Terraform and Ansible as the examples. So what is Terraform doing? Terraform is doing infrastructure provisioning and management. What is Ansible doing? Configuration management and application deployment. Now, what is the type of Terraform? Terraform is called declarative. And what is type of Ansible? Primarily imperative. You would see that most configuration management tools are imperative and most infrastructure provisioning tools are declarative. In declarative, you would say this is the desired state. Terraform would ensure that the desired state is the same as the state in the cloud platform. In Ansible, it's imperative. You will give step-by-step tasks. Do this, do this, do this. So you'll give step-by-step tasks. If you want to make a change, in Terraform, you just update the desired state. What does Terraform do? It will compare the desired state with the actual state. It will identify the changes and it would apply them in the environment. So you do not need to think about the changes. You just need to say what you would want to have at the end. And Terraform would make that happen. However, in Ansible, if you want to make a change, you'd again need to write a new instruction to make the change. You need to create a task to make the change. There are a lot of other differences between declarative and imperative approaches, and there are specific reasons why Terraform uses declarative approach. We will dig deeper into them as we go further in this specific section. For now, the important thing for you to remember is that Terraform is declarative, Ansible is imperative. Primary use of Terraform is to create, modify, and delete cloud resources. The primary use of Ansible is to configure, manage applications on existing servers on the cloud. These servers can also be on-premises. So whether the servers are on-premises or in the cloud, you want to configure and manage applications or operating system or processes or files on existing servers. Terraform uses a language called HashiCorp Configuration Language, HCL. This is the mostly used language with Terraform. In Ansible, the mostly used format is YAML-based playbooks. You'll write a playbook containing your imperative instructions, step-by-step tasks. How does Terraform do state management? Terraform maintains the state to track infrastructure changes. Whenever Terraform creates something, it has the state. It knows what it did previously. Tools like Ansible don't manage any state. They are stateless by default. Terraform is great at creating and managing infrastructure at scale. Ansible is great for configuration management. However, it's less efficient for provisioning. Terraform focuses on provisioning infrastructure on cloud providers like AWS, Azure, and Google Cloud. On the other hand, Ansible is recommended for configuration management on both cloud and on-premises infrastructure. Terraform offers limited configuration management capabilities. On the other hand, Ansible is excellent for configuration management. So it's excellent for configuring apps, services, files, and operating system on existing servers. So my recommendation is use Terraform for provisioning and Ansible for configuration management. Tools like Terraform or Pulumi are great for provisioning, and tools like Ansible, Chef, Puppet, these are great for configuration management. In this step, we compared one infrastructure provisioning tool with another configuration management tool. We compared Terraform with Ansible. I'm sure you're having a great time, and I'll see you in the next step. Welcome back. Now that we have a high-level overview of Terraform and how it fits among the different tools that are present in the infrastructure as code landscape, let's dig deeper into Terraform. Let's talk about how you can use Terraform to create resources in the cloud. What you would start doing is creating HCL configuration file. So you would need to define your infrastructure, the resources you would want to provision in the cloud. You'd want to define them in a file with the extension .tf. This is called a HashiCorp configuration language. So .tf files, whatever you write in there, you are writing it using the HashiCorp configuration language or HCL. Now let's look at an example, right? So let's say I would want to talk to AWS. I would want to provision resources in AWS. What do I want to create in AWS? I want to create a S3 bucket. S3 is object storage in AWS. What do you use object storage for? You can store backups, you can store static files, you can store logs, you can store any files that you would be able to typically store on your local machine. You will be able to store them in S3. So S3 is object storage where you can store a wide variety of files. These can be backups, static files, logs, or any other files. So what we want to do is to go to AWS and create an S3 bucket in AWS. So when I would want to go to AWS, I would need to configure which region in AWS I would want to make use of. Let's say I would want to make use of the US East 1 region. This is typically the most used region. And whenever you're creating a S3 bucket, you can say, I want to create a S3 bucket with this specific name. And this name should be globally unique. And we also want to enable versioning on the S3 bucket. Whenever a new object is uploaded or whenever actually an existing object is updated, I'd want to also have the old objects available. So I'd want to implement versioning. I'd want to keep history. So I'm enabling versioning. So if I would want to create a S3 bucket in AWS, the first thing I would need to say is provider AWS. Now, what is the use of a provider? Terraform needs to know how to talk to the cloud platform, how to authenticate to the cloud platform. That's what a provider enables you to do. Provider enables Terraform to talk to the cloud provider, to authenticate itself with the cloud provider. And you can also specify the region where you'd want to create your resources inside the provider. So this is needed for Terraform to know where and how to create resources. Next, we are now connected to AWS. So we need to say, I would want to create an S3 bucket in AWS. How can you do that? That's where you need to define something called a HCL resource. Simply, you can call this a resource. When you configure a resource, first you need to configure the resource type. I would want to create a AWS S3 bucket. This is a standard resource type. Whenever you would want to create a S3 bucket, you need to specify the same resource type. And this is the internal name we are using to refer to this specific instance of the AWS S3 bucket we are using. So this is just an internal name. And what we are doing is we are configuring the name of the actual bucket to create in AWS in here. This bucket name should be globally unique. And we are saying we would want to enable versioning. If you'd want, you can add tags as well. Any object that you create in AWS, you can add tags to it. For example, what is the name of the application? What is the name of the project? Who is responsible for the cost of this specific resource? All that can be represented by using tags. So now we have said we would want to talk to AWS and we would want to create a resource in AWS. Let's say I would want to create another resource in AWS. I would also want to create an IAM user in AWS. In that kind of scenario, I would want to create another resource. You can see that there's a key difference between these. This is the AWS S3 bucket and this type is, the resource type here is AWS IAM user. So you'd want to create an AWS IAM user. And what is the name of that specific user? It should be my IAM user. So this would actually create an IAM user, identity and access management user. So we are creating an IAM user. So what we are doing in here in this specific script is connecting to AWS and saying we would want to create two resources. I would want to create an S3 bucket and also I would want to create an IAM user. Let's get back. Let's now continue talking about how you can use Terraform to create resources. So the first step is to write a HCL configuration file. So you would create a Terraform file or .tf file to define infrastructure. I want to create a S3 bucket and I would want to create an IAM user. And you'd be using HashiCorp configuration language. There are a lot of other things you can define your Terraform files. We'll be discussing them as we go further. For now, let's focus on the big picture. So you have a Terraform file ready. What do you do next? Next, you need to run Terraform init. Now, what does Terraform init do? We said we would want to create resources in AWS, right? Terraform by default does not know how to create resources in AWS. It needs to first download the provider. Terraform init helps Terraform to download the necessary provider plugins. And it would also set up the local working directory. So the project working directory would also be ready for use. Next, I would want to validate the configuration. I've created a Terraform file, but I'm not sure if it's perfect, right? I would want to validate it. So what I can do is Terraform validate. This can check for syntax errors or misconfigurations before we take any action. Next is I would want to find out what kind of changes would be done in the cloud. We know that creating cloud resources can be really, really expensive. And that's why even before we create our resources, we want to be sure what Terraform will be creating, updating, or destroying. This would help prevent surprises. That's what Terraform plan enables us to do. When you run Terraform plan, Terraform says, hey, I'm going to update one resource, or I'm going to update two resources, or I'm going to create two resources. So it will give you information about what would happen if you execute this specific configuration. And after that, once you are sure about what the changes are and once you are okay with it, you can run Terraform apply. Terraform apply would execute the changes that are shown by Terraform plan. It would actually provision the defined infrastructure. So you can see that when you'd want to provision infrastructure using Terraform, these 5 steps are involved. First, you write HCL configuration files, you initialize the project, you validate your configuration, you do the plan, check what changes would be done by Terraform, and then you do an apply. Once you do this, all the changes you have defined in HCL would be applied on the cloud platform. Now, if you want to do changes, let's say I'd want to provision another AWS resource, or I would want to make a small change in the S3 bucket. If you want to do something like that, you can update the .tf files. So you can update the TF files to include the new resources or include the changes. For example, I would say I would want to add tags. So I've already created a bucket, but while creating the bucket, I forgot to add tags. So let's say I would want to add tags in. So I can update the TF file to add the tags in. And what I can do is again execute the plan. So when I say Terraform plan, Terraform would see that the bucket already exists. However, the tags are not enabled. So it would compare existing resources in the cloud with whatever we want. It compares desired state with the actual state. And it finds out that only the tags are missing. So what does it do? Will it create the resource again? Nope. What it does is it will tell you, hey, I need to update this specific resource, which is your AWS S3 bucket type, my S3 bucket. So we want to update this and add tags on it. That's what Terraform plan would tell you. So if you modify the .tf file and execute Terraform file, it will tell you the changes that Terraform will do if you do Terraform apply. If you do Terraform apply, then Terraform executes whatever is necessary to add tags to the bucket in AWS. So this is the change cycle. Whenever you want to perform any change, then you would modify the TF files. You would say plan, Terraform plan, and Terraform plan will tell you what would change. And once you are okay with it, you can go ahead and say apply. The last step, once you have made use of the resources, once you want to terminate the environment you have created, you can execute Terraform destroy. Terraform destroy would automatically tear down all the infrastructure that is defined in your Terraform files, which is provisioned using this specific Terraform script. You can see that Terraform is declarative and predictable. You define the desired outcome. Terraform will compare the actual state. It will compare the desired state with the actual state in the cloud. And it figures out the actions it needs to perform to easily apply your desired state in the cloud. In this specific step, we got a high-level overview of how you can use Terraform to create resources. I'm sure you're having a great time, and I'll see you in the next step. In this specific step, let's focus on why Terraform is called a declarative tool. As we said earlier, Terraform uses a declarative approach to define infrastructure as code, compares it with the real world state, and apply only the necessary changes to match the desired outcome. So you describe what you want and not how to get there. Terraform figures out the steps. So we avoid step-by-step instructions. We only tell at the end, this is what I need. I'll write a HCL file saying this is what I need. Check against the cloud and implement it. So we would define our desired state using HCL. So we write .tf files to describe the end result. An EC2 instance must exist with a certain type and AMI. Terraform would go ahead and execute the plan. It compares your configuration with the current infrastructure state and shows what it will create, update, or delete. It will only execute the minimum required changes to apply your desired state in the cloud. So Terraform would apply the minimal set of actions needed to bring real infrastructure in sync with your code. Terraform also keeps track of resources in a state file. This is called Terraform state. Terraform maintains a snapshot of managed resources. So what Terraform does is once the actual infrastructure is created, the real infrastructure is created, it would create a local state of what's been created in the cloud. This is a snapshot. This is called Terraform state. And this is used for future comparison and updates. Every time you'd want to make a change, Terraform does not go to the cloud and compare actually against the actual resources. What it first does is it would compare against the local state that it has. And only then it would compare against the actual resources. So Terraform is very, very efficient in that sense. It maintains a local snapshot called the Terraform state, where it knows the state of last execution. What was the state in the cloud when the script was last executed? That is called Terraform state. So what we are talking about is the fact that Terraform uses a declarative approach. In an imperative approach, you tell the system how to do each step. Create a subnet, launch a VM. So that's what you do in an imperative approach. For example, if you are using shell scripts, if you're using Ansible, you do step-by-step instructions. However, we are talking about the fact that Terraform uses a declarative approach. You declare the final outcome. You'll say, I want this. You compare what's in the cloud and you decide how to implement the changes. Now, you might be wondering, why does Terraform take a declarative approach? In my view, by taking a declarative approach, you get safer and more predictable changes. You don't need to give step-by-step instructions and therefore you'll have less errors. Some of the advantages of declarative approach is execution plan visibility. Terraform provides a detailed preview of all actions. When I execute Terraform plan, it says, okay, these are the resources which will be created, updated, and deleted. So this will help you to catch unintended consequences. If the script, by mistake, if your script is going to delete a production resource, or it's going to alter a critical security group, then you'll find it early because you would execute a Terraform plan and then you'd find it out. Next, idempotent behavior. If you run the same configuration multiple times, it will yield the same result. If whatever is defined in your script is actually present in the cloud, then Terraform will not do any change. It will say, hey, no change is required. But imagine you are using an imperative style and you execute the script twice. Let's say the script is creating a virtual machine. Then what it will try to do second time you run it, it will try to create another virtual machine. So the advantage of the declarative approach is idempotent behavior. Even if you execute the same script twice, the first time the script runs, it executes the change. But the second time the script runs, it knows that the exact state in the cloud matches whatever is in the script. So there is no change needed. Next, minimizes human error through automation. When you are writing Terraform scripts, you are not writing step-by-step logic. writing imperative step-by-step logic is complex. However, when you're using Terraform, you'll just say, okay, these are the resources I would need. Terraform would compute the dependencies. Terraform understands the dependencies between different resources. It knows which one to create first, which one to create next. So all that you need to say is, okay, this is the final state. And Terraform can identify the dependencies and identify how it can create the resources. It knows that I want to first create a security group, or I would want to first create a network and then create a security group. And then I would want to create a virtual machine. So Terraform knows this order, and therefore it can decide the step-by-step logic by itself. You don't need to focus on the step-by-step logic. And this would reduce the risk of mistakes. And last thing is creating new environments safer. You know that all the changes that you would want are defined in the final state. The final Terraform code that you have is the final state after maybe making 10 or 15 changes. You know that that is the exact state in the cloud. And therefore, whenever you want to create a new environment, you know that everything that is needed in that environment is defined in the code, because it is coming from an old environment and it is version controlled. So this would ensure that every environment, dev, QA, stage, production, is built with the same structure and settings, making deployments consistent and repeatable. Terraform provides features where you can configure what you'd want in a specific environment. Maybe in production, I would want 10 instances. In dev, I would just want 1 instance. You can do things like that by providing parameters to the scripts you are running. But you know that the actual script is exactly the same. You know that this script has been used in a specific environment earlier to provision things. So you can be really, really confident about this script. In this specific step, we talked about why Terraform is called a declarative tool. And we also discussed some of the advantages of Terraform being declarative. I will see you in the next step. Hello, this is Ranga from In 28 Minutes. Do you know we have almost 2 million learners learning from our courses on Udemy? And another thing you might not know, interview questions you have watched until now are from a course called Cloud and DevOps Interview Guide. With over 300 questions, it is the best cloud and interview guide in the world. Why am I so confident? First of all, we cover a wide range of topics. We cover 3 cloud platforms, AWS, Azure, and Google Cloud. And we also cover a wide range of DevOps tools, Git, GitHub, Docker, Kubernetes, Terraform, and beyond. Our goal is to continuously update the course as the DevOps space evolves. Check out the full course using the link below. We added in a special discount for our YouTube learners in the link. So do check the link out. And there's even more. We are giving away free access to the course every month to 100 lucky learners across YouTube. Here's how you can win. Just post a detailed review of the video on LinkedIn, sharing what you have learned in the video. And don't forget to tag In 28 Minutes and also me, Ranga Karnam. Thanks for watching and happy learning. Until I see you again, here's bye from Ranga at In 28 Minutes.